Good morning to all. Today we are going to discuss about mobility of mechanism. Before going to mobility, we have to we will recall some basic information of mechanisms. First, we are going to define a link. A link is a name given to any body which has relative motion with each other. So there are three different types of links. They are binary link, ternary link, quaternary link. Binary link is the link which is connected to two other links at two different points. So we can see in the figure A, here this link can able to connect at two ends. So two points are there to connect with another link. So it is a binary link. Next, ternary link. So ternary link, it will connect other links at 3 points. Similarly, the quaternary link will connect the other links at 4 points. These ternary and quaternary links are shown in figure B and C. Here 3 points are there to connect with other links, and here 4 points are there to connect with other links. Next, we are going to define about a kinematic pair. A kinematic pair is one in which two links or elements of a machine will contact with each other, and they will be having a relative motion which is completely or successfully constrained. So if two links are connected with each other and there is a relative motion, then it is called a kinematic pair. Next, different types of kinematic pairs are there. In this, we are going to concentrate on only lower pairs and higher pairs. So lower pairs is that when two elements of pairs have surface contact. So surface contact means the surface area will be in contact when the relative motion takes place. Then it is called lower pair. In this sliding and turning pairs, the shaft having a surface area is in contact with the collar or hole. Similarly, in this rectangular surface is in contact. So it is a surface contact. So it is called as lower pair. In higher pairs, the two elements will have line or point contact. So line or point contact. So line or point contact means, for example, if you see the roller bearing, only a portion of the roller, that is a particular point of the roller is in contact with the outer race and inner race. So it becomes a higher pair. Similarly, gears. In gears, we will be having only the line of contact. Line of contact will be there between two gears when they are meeting. So it also becomes a higher pair. So we can easily differentiate between lower pair and higher pair. Main thing is, if there is a surface contact, it is a lower pair. If there is a line contact or point contact, it is a higher pair. Next one, types of joints. In these types of joints, we are having three types of joints: binary joint, ternary joint and quaternary joint. So this joint is when two links are joined at a single place, then it is called binary joint. Here in the figure we can indicate those by B. B means binary joint. Here at this joint, this link and this link are connected at this joint. So at this joint we are having only two links. So it is a binary joint. Similarly, in ternary joint we will be having three links connected at single joint. In the quaternary joint, four links are connected at the same joint. So T indicates the ternary joint, Q indicates the quaternary joint. See here at T, this is one link, this is one link and this is one link. So three links are going to connect at single point. So it is a ternary joint. Similarly in quaternary joint, this link, this link, this link and this link. So these four links are connected at a single joint. So it is a quaternary joint. So generally, if n number of links are connected at a joint, it is equivalent to n minus 1 binary joints. So here if we see in binary joint, here two links are connected at this joint. So it is equal to 1 binary joint. In ternary joint, three links are connected. So 3 minus 1, 2 binary joints. It indicates that the ternary joint is equal to 2 binary joints. Similarly, quaternary joint is equal to 3 binary joints. Next, we are going to define kinematic chain. Kinematic chain is one when number of pairs are coupled in such a way that the last link will be joined to the first link to transmit a definite motion, that is successfully constant motion or completely constant motion. So it forms a closed pair. So then it is called kinematic chain. Next one, we are going to define a degrees of freedom. So degrees of freedom is that the number of independent coordinates required to describe the position of a body in space. So here see in the figure, a cube is there. It can freely move or rotate in a three-dimensional space. So if it is rotating or moving, it will rotate in x direction, y direction and z direction. Similarly, it will translate in x, y and z direction. So totally it will have 6 degrees of freedom. So any body in space will have 6 degrees of freedom. So these degrees of freedom may reduce by constraining any one direction. So it can be happened in kinematic chains because two links are connected and form a pair. So one of the degree of freedom will be reduced. Similar like that, if the joints are connected, we can reduce the degrees of freedom of a body. So if it is not connected and freely in space, as shown in figure, it will have 6 degrees of freedom. Next, now we are going to define mobility. So mobility of a mechanism is that the number of inputs required to describe the position of all links in the mechanism with respect to the fixed link at any given instant. So here, see in this 4-bar chain, link 1 is fixed. If we move the link 4 alone, we can able to move all the links. So the mobility of this 4-bar chain is equal to 1. Like that, in this 5-bar chain, we have to move either both link AE and link BC, that is link 5 and link 2, theta 1 and theta 2. If we rotate these two links, then only we can achieve the motion of the total mechanism. So it requires mobility is 2. Like that, we have to identify the mobility of the mechanism. To identifying the mobility of the mechanism, criteria is there which is given by Kuchbak. In Kuchbak criteria, the mobility of mechanism is defined by using this equation. Here n is equal to, n is mobility of the mechanism, that equal to 3 into L minus 1 minus 2j minus h, where this L is the number of links in the mechanism and j is the number of joints forming lower pairs in the mechanism, and h is the number of joints forming higher pairs in the mechanism. So this equation is given by Kuchbak criteria and is used to find the mobility or movability of the mechanism. So by knowing the types of links and types of joints and types of pairs, that is lower pair or higher pair, whether it is a ternary joint or binary joint, we are going to calculate the mobility of the mechanism. Thank you.